Absolute value equations. How do we solve these absolute value equations? Well, suppose we have something like the absolute value of x is equal to 5. Here, what this means is x is 5 units away from 0. On a number line. So if we have a number line like this, let me do that again. Ugly number line. Here is 0. You get 1, 2, 3, 4, 5. Then x would be 5 units away from 0. So we can say that x is equal to 5, or we can also say x is equal to negative 5, because if I choose to count from the left side, 1, 2, 3, 4, 5, I'm still 5 units away from 0. Let's take another example, something a little more complicated perhaps. X minus 2, absolute value of x minus 2 is equal to 10, for example. Here, there are two ways to look at this. You can say that this quantity is 10 units away from 0, or some value of x is 10 units away from 2. Either way, but the way to set it up would be this way. This is how I would set it up. I would make a table. If I can make my tables a little straighter, I can say that x minus 2 equals 10, or I can say that x minus 2 equals negative 10, and then I can just solve for x. So here x would be equal to 12 by adding 2 on both sides, and here I would get x is equal to negative 8. Now if you were to check it, you could say that the absolute value of 12 minus 2, this gives me 10, and the absolute value is 10, so 10 is equal to 10, so it checks. If I choose the negative 8 value, then the absolute value of negative 8 take away 2 is the absolute value of negative 10, which is 10, and 10 is always equal to 10, of course. If we choose a problem a little more complicated than that, let's take, for example, the equation 2a minus 1 is equal to 7, for example. Here, what this is saying that 2a minus 1 is 7 units from 0. So the quantity is 7 units away from 0 on a number line. Okay, that's the way to think about it. But to solve it, you would say 2a minus 1 equals 7, or 2a minus 1 equals negative 7. Solving this one, you can add 1 to both sides. We get 2a equals 8, or a equals 8 divided by 2 is 4. There's one solution. Over here, we can say that 2a minus 1 equals negative 7. We can add 1 to both sides. We get 2a equals negative 6, or a must be negative 3. And if you substitute these values, we can always check. Never forget to check, especially with these absolute values. I'll give you one more. Say we have something with fractions in it. Suppose I have 2/3. I'm sorry, let me do that again. 2/3 x minus 3 is, plus 5 equals 12. Well, first of all, we need to isolate our absolute value part, eliminating this 5. So we subtract 5 from both sides. Then the absolute value of 2/3 x minus 3 is equal to 12 subtract 5, which is 7. And again, we can say that this quantity is 7 units away from 0. So to solve it, we can just say 2/3 minus 3 equals 7, or 2/3 x minus 3 equals -7. And then, of course, I can solve for x on both of them. 2/3 x equals 10. Here I need to multiply both sides by the reciprocal, which is 3 over 2. 3 over 2, that eliminates the 3, eliminates the 2, dividing, giving me a 1 times x, or just x. 2 goes into 10 5 times 3 is 15. On the other side, 2/3 x will be adding 3 to both sides. -7 plus 3 is -4. 2/3 x equals -4. We need to multiply both sides by the reciprocal of 2/3, which is again 3/2. 3 over 2. Eliminating our fractions here. X will be equal to -4 times 3 over 2. 2 goes into 4 twice. And that gives me -2 times 3, which is -6. And again, we have two solutions. Now, for even a more complicated problem, because they can always get more complicated, suppose I have, or rather you have, something like 3a plus 1 is equal to the absolute value. The absolute value of 3a plus 1 is equal to the absolute value of 2a minus 4. Well, now it looks weird, because now you have absolute value on both sides of the equation, but technically you set up there are the same steps. What we do is we say 3a plus 1 equals 2a minus 4, or 3a plus 1 equals the negative of 2a minus 4. Solving this equation on the left over here, 3 take away 2 gives me 1a plus 1 equals -4. Subtract 1 from both sides, so a equals -5. There's one solution. Now here we have to distribute the negative, so I get 3a plus 1 equals the negative of 2a, and the negative of a negative makes it a positive 4. Here we get to add 2a to both sides, because we can only have a's on one side. So we're going to have 5a plus 1 equals 4, or 5a equals 3. Dividing both sides by 5, a must be 3/5. As you can see, we got two solutions, and of course, always double check your answers by substitution.